Distant galaxies redshift. The orthodox reading is that space itself stretches, carrying the galaxies apart and drawing out the wavelength of light in flight. But on this substrate there is no space to stretch. The lattice spacing is fixed, it is a rigid ruler, and it does not move. So what gives? What drifts instead is the emergent light speed, because the condensate carrying the cone slowly breathes. A photon born when the cone was fast, arriving into a cosmos where the cone has slowed, comes stretched, red-shifted, and not 1 meter of space has moved. So this chapter has a double case to make. First, show that this slowing cone picture reproduces the standard cosmological kinematics exactly, and it does, with a scale factor that is simply the reciprocal of the cone speed. Second, and much harder, find the law that says how the cone speed evolves. Because in the kinematic picture that law is missing. The scale factor is put in by hand. We are going to find the culprit that supplies it, and then deliver a verdict you will not like. The law exists. It is Nordström's, not Friedmann's. One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Here is the kinematic half, and it is clean. Take the substrate in its locked, condensed phase, and let the intersite stiffness be spatially uniform, but slowly time-dependent. Nothing about the lattice is spatially distinguished. That is the cosmological principle, imposed right at the substrate level. The emergent cone speed then inherits that time dependence. C effective squared is the lattice spacing squared times the stiffness over the inertia, with the spacing and the inertia both fixed. So a massless goldstone, a photon of the emergent field, propagates on an ultrastatic optical metric with a time-varying cone. Now write that line element down and put it next to the spatially flat Friedmann-Robertson-Walker line element. Stare at the two for a second. The identification is immediate and it is forced. The scale factor is 1 over the cone speed, and the Hubble rate is minus the fractional rate of change of the cone speed. A slowing cone is an expanding universe. That is the entire kinematic content of ACT cosmology, and I want to be exact about credit. This is the analog FRW construction from the condensed matter literature, Unruh, Visser, Volovic. We tag it standard and hand the credit back. Now the consequence that makes the picture worth having. Take a wave crest emitted at one time and observed at another, and impose the null condition. 2 successive crests separated by a fixed coordinate interval give you the standard relation, and in cone speed variables it reads 1 plus z equals the cone speed at emission over the cone speed at observation. Same formula as the textbook. Completely different story underneath. The wavelength is not drawn out by receding space. It is fixed in lattice units at the moment of emission, and it stays fixed. What changes is the local conversion between lattice units and meters, which is the cone speed. So a photon emitted when the cone was 1% faster arrives redshifted by about 1%. No galaxy has moved through the lattice. The ruler that reads it has rescaled. And the friction is real too. Put a massive matter field on this background, write out the covariant wave equation, and a 3h chi dot term appears, genuine Hubble friction, damping every field riding the expansion, redshifting momenta, cooling the contents. One detail matters, and it is a self-correction from the source. That is a wave equation. Second order in time, with the friction as a first-order drag. An early draft wrote the homogeneous relaxation as diffusion, first order in time, and got both the character and a sign wrong. The substrate is deterministic and time-reversible, axiom A1, and a first-order diffusion law would violate that. Reversibility forces the waveform. Now stop and notice what we do not have. Everything so far is kinematics. It takes the cone history as given and reads redshift and friction off it. What it does not contain is a field equation for the scale factor itself. Nothing here sources the expansion from the energy content of the universe. In Friedmann language we have the geometry, and we do not have the Friedmann equation. The scale factor is prescribed, put in by hand. That is the gap, and most analog cosmology simply stops here and leaves the sound speed externally driven. But we can close it, because the object we need is already in hand. Chapter 12 showed the lapse of this theory is not a background label but a dynamical field, the dilaton, the log amplitude of the condensate, which propagates and self-sources, and the cone speed tracks the condensate amplitude by the protected identity of Chapter 10. So the dilaton is minus the log scale factor. A falling condensate amplitude is a slowing cone, is an expanding universe. 3 statements. 1 fact, and the sign is fixed by the definition rather than chosen. So take the homogeneous mode of Chapter 12's Dilaton equation, restore the Hubble drag, and there is the law. A massive, sourced wave equation for the log of the scale factor. The scale factor is now determined by initial data plus a source, exactly as a cosmology should be. Gap 10's complaint is answered. But note how it was answered by inheritance, not by a new mechanism. Nothing in that equation was built for cosmology. It is Chapter 12's gravity equation restricted to its spatially constant mode, which means it arrives carrying Chapter 12's defect welded on. The verdict turns on one feature of that equation, the source. Look at what sits on the right-hand side. It is the trace of the stress tensor minus rho plus 3p, and not the energy density. The Friedmann equation is sourced by rho. A scalar gravity sourced by the trace is Nordström's 1913 theory, and now evaluate it. For a photon gas, or any conformal matter, the pressure is a third of the density, so the trace is minus rho plus 3 times rho over 3, which is exactly 0. The source vanishes. Radiation drives no expansion at all. Put a blackbody at 1 billion Kelvin into the box, and it contributes nothing to the sourcing, no matter how large its energy density is. Now, why is that fatal rather than merely curious? Because the real universe is radiation-dominated at early times, and it is precisely then that the expansion history is most tightly constrained, nucleosynthesis the acoustic peaks. A cosmology in which radiation exerts no pull on the scale factor cannot reproduce the radiation era. This is not a modeling artifact to be tuned away. It is the classical, decisive objection that killed Nordström cosmology a century ago, and this theory inherits it in full. The dust era does survive. Pressureless matter has a non-zero trace, so it does source the dilaton. The theory is not empty. It is simply the wrong sourcing for the observed cosmos. Two further inheritances complete the picture, and both come straight from the gravity verdict. First, the dilaton is massive. That mass term makes the expansion force Yukawa ranged, with a range equal to the condensate healing length, the cone speed over the gap frequency. Take the healing length to be microscopic as it is, and that range is vastly shorter than any cosmological scale. There is no long-range cosmological dynamics here at all, unless the gapless lapse rescue succeeds, and Chapter 12's dichotomy theorem argues the lattice forbids it. Second, there is no Friedmann constraint. What we derived is a propagation equation, not an energy constraint relating h squared to rho. And here is the part worth holding on to. The kinematics of the first half survive completely untouched. Redshift, Hubble friction, the scale factor dictionary, none of that ever needed the sourcing. What is scalar rather than tensor is the dynamical law underneath. So the result is a cosmology that is dynamical but scalar, which is the same verdict as the gravity it is built on. And that agreement is the point, not an embarrassment. The cosmology does not secretly outperform its own gravity. If it did, one of the two derivations would be wrong. Verdict. The kinematics are exact, and they are standard. A slowing cone is an expanding universe, with the scale factor the reciprocal of the cone's speed, and redshift that needs no stretching space at all. The missing law is genuinely supplied. The homogeneous mode of the dilaton gives an evolution equation for the scale factor, so gap 10 is honestly closed. And the closure is a downgrade, because the law is sourced by the trace and not the density. Radiation does not gravitate. The radiation era cannot be reproduced. That is a real falsifier, and this theory fails it as a literal model of our universe, stated plainly, not softened. What would change the verdict is not a cosmological calculation at all. It is a substrate-level proof that a locked lattice can carry an exactly gapless spin-2 mode. If Chapter 12's frontier were crossed, this law would upgrade automatically. A density-sourced Friedmann constraint would replace the trace-sourced scalar equation. Radiation would gravitate, and the radiation era would come back. Chapter 12 argues the lattice forbids exactly that. So the tension is the frontier, not a gap in the cosmology. Next, let the cone vary in space rather than in time. Add a flow, and the same breathing condensate that reddens a distant galaxy will trap a wave at a horizon. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shivalinga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, the book and the next chapter are linked below. Until then, one substance and how far it reaches.